fourth method is angle side, AAS, right? So now the side is non-included. We can kind of see that. It's written over there on the edge, okay? That means that it's not formed by the two angles that we care about. The two angles we prove congruent. The side between them doesn't work anymore. We need a non-included side. What that means, a little different now. What that means is we have two choices for sides that we can work with. Okay? So a little bit different. Let's look at how this actually looks in a proof. Here's what we have here. We have AD is parallel to BC, and AD is also congruent to BC. We only have two givens here. We're going to have to kind of make up a lot of information on our own, and that's okay. We can do this. We are trying to prove AED congruent to CEB. What does that look like? It looks like AED congruent to CEB. That's the goal. That is the goal here, is to get those two, the triangle on the left and the triangle on the right, to be congruent. Start with the given. Here we go. In the given, we have that AD is parallel to BC, and we have that AD is congruent to BC. So it's both congruent and parallel. Mark off that it's congruent. And then we've pretty much done everything we can with that piece of the given. Done. Nothing more we can do. If it's congruent, we stop. We know they're the same length. We know that means they're identical. We don't care. Congruent is where we stop. Well, the reason for all this is because it was given to us. Then, because it was given, now we can take and build ideas from that. Let's go back to this idea of parallel. With angles, we're working with angles. We've got the side we want, right? This is a side. We've kind of hit the max on the side. Now we have to talk about the angles. And with this idea of angles and parallel, we want to look for probably alternate interior angles because we live on the interior of the triangle. That's usually how it's going to go. What we have here are two alternate interior angles. We can think of this line here as extending off and becoming transversal. We have a pair of alternate interior angles here. We can say that DAE is congruent to BCE. Why? Because they are alternate interior angles. I don't want to confuse you, but this is something to think about. We also could have gone with that as our transversal. And then we would have had some angles in the corner here that would be congruent. With that, with those alternate interior angle pairs, now we have angle, side, angle, which is what we just talked about. That's not really what we want to use right now, so I'm just going to undo all that. But it's something to keep in the back of their mind. Some of these proofs can be attacked in two different ways. Okay? I want to show you how to do it where you use a different angle so that your side is not included. What that means is I can't take angle D down here because then my side is squished between. What that leaves for me is the other angle. And of course, those are vertical angles. We love vertical angles, so let's use them. AED, that angle, is congruent to CEB. Why? Vertical angles are always congruent. Vertical angles are always congruent. We know that. So let's use it. When it's there, please use it. It helps you. Let's look at what we have here. picture, we have an angle and an angle, and we have a side that just kind of swings freely. From angle, angle, side, we can say that our two triangles here are congruent. Little recap. We started with one side being congruent in the given. It was told to us. We didn't have to work for it, it was just there. Because of the parallel lines, we were able to come up with a pair of alternate interior angles. Technically, we came up with two, but for our purpose here in the proof, we just wanted one. The other angle were the vertical angles, right? And because we were using angle, angle, and then a non-included side, because this side here is not included, it doesn't touch that other angle. If it's included, it has to touch both. It doesn't intersect the middle vertical angles there. Because of that, we have angle, angle, side as our reason for our proof, and these two triangles are congruent.